Assalamu alaikum. Welcome everyone. So today we're going to be working on the question on the screen that says estimate the increase in the molar entropy of O2 gas when the temperature is increased at constant pressure from 298 kelvins to 348 kelvins, given that the molar heat capacity at constant pressure of O2 gas is 29.355 joule per mole Kelvin at 298 kelvins. So to solve this, the first thing you have to do is understand what you're asked to solve for. They didn't ask us to find the molar entropy of a particular value. They asked us to estimate the increase. So anytime you see that you're asked to find an increase in something, that just means that you're trying to see how much of the molar entropy has increased. So you're going to be dealing with the initial molar entropy as well as the final molar entropy. So we're dealing with a question where there's a temperature increase at constant pressure. So the pressure is constant all through, but we have an initial um, temperature and a final temperature. So the initial temperature for this question, for this entropy question, is 298 kelvins. And then we're told the increases to 348 kelvins. So the final temperature is 348 kelvins. So given that the molar heat capacity at constant pressure of O2 gas is 29.355 joule per mole Kelvin. So the molar heat capacity at constant pressure of O2 gas is 29.355 joule per mole Kelvin. So that is basically the question. So the first thing you have to know is anytime you're given a question for entropy, note that when you're told that this is occurring, um, and you're given the initial temperature as well as the final temperature as well as the molar heat capacity of a particular gas at a particular temperature, you're going to be using this formula here, which is um, entropy TF, okay, equals entropy T initial plus Cp comma M, okay, ln T final divided by T initial. So this is basically how you work up with a problem like this. This is basically how it's done. I apologize for the scribble. So this is basically the equation. So yeah, that's it. So you're looking for the entropy at the final temperature, and then the entropy at the initial temperature, then the molar heat capacity times the ln of the T final divided by the T initial. Since we're not asked to find for the molar entropy at the final temperature or the molar entropy at the initial temperature, and we're asked to actually find the increase, we're going to be dealing with the change in molar entropy. So to rewrite the formula, we can have the change in molar entropy for this question can be written as this. So T final minus molar entropy T initial, and then we have Cp, comma M ln T final divided by T initial. So change in S is now basically Cp, comma M. So molar, the molar heat capacity at constant pressure times ln T final divided by T initial. So this is actually what you're going to be working with. So of course we've reached this point. We're just going to substitute whatever we have. So we have change in S is equal to the molar heat capacity at constant pressure for O2 gas is 29.355 joule per mole Kelvin times ln T final. So that would be T final, we know that to be 348 kelvins. We know T initial to be 298 kelvins. So that's basically how it's done. Of course, we have the change in S. It's equal to 29.355 joule per mole Kelvin times ln 348 divided by 298 kelvins, of course, because we have the same units, we can just cancel out the Kelvin. So that would be ln 348 divided by 298 is the same thing as ln 1.1678. So that's basically how it's done. You can input this information in your calculator. 29.355 times ln 1.1678 will give you the change in S to be 4.5536 joule per mole Kelvin. Now, I wanted to mention that we've gotten our answer to be correct, thankfully, but we have to go back because we're dealing with chemistry. We have to see the lowest number of sig figs that we're given in order for us to pick this final answer. So we have 3 sig figs for 398. 348 also has 3 sig figs. Here it has 5 sig figs. So we're going to actually approximate our answer to 3 sig figs. So having that 3 sig figs, we have our change in S to be plus 4.55 joule per mole Kelvin. And I wanted to mention this. It was very important to say anytime you're dealing with entropy question, make sure you always put a plus or a minus because it's very, very important in entropy. It's not like the previous physical chemistry problems that we've had where a positive value, we can just ignore the plus. There are so many change in entropy and molar entropy questions that can take the negative sign. So just make sure you put that into consideration and just add your plus, even though, of course, the positive can be omitted. But just for this particular topic in entropy, try to add your plus as well as minus so that you can easily differentiate and be easy for your teacher to mark. If you're a student who's trying to succeed in all your STEM related courses, I tutor students in your STEM related classes how to succeed and how to be the best version of themselves in your academic career. So if you would like to book a session, you can email me at shohabitutoring@gmail.com. I wish you guys all the very best. If you have any questions, put in the comment section. If you have any suggestions or concerns, also put in the comment section. Assalamu alaikum wa rahmatullahi wa barakatuh.